Okay, so the first thing I'm going to talk about here are SHAP force plots, and these are the type of plots that we're going to interpret when we're using SHAP to understand our machine learning classification at the voxel level, so at a local level. Okay, so here's what a force plot looks like. We're looking at it in this channel area right here marked by the purple star, so from our random forest classification. And what we're seeing here is a couple of different things. I'm going to break them down. Hopefully I don't miss anything, but we've got our 6 different attributes that we put into the random forest classification, and they're all kind of colored in this red color and headed off towards the left, okay? So that they're all red means that the value of these attributes is making it a higher probability that it's classified a channel. And you could see we had 3 different seismic facies we could classify. So it starts off at 0.33% probability, because if you know nothing, there's a third of a chance that it's a channel, a third of a chance it's a turbidite, a third of a chance it's background shale. So everything builds up at that 0.33. And overall, the confidence level is 92% that it's a channel in that random forest. So a couple of things to pay attention to. So here I've circled in blue. Red means that that value is leading it towards a higher chance of being classified as that class, so a channel. Blue would be a lower chance. We've got our base value, so that's that 0.33 because there's 3 different options. And then we've got our final kind of like prediction value or confidence, which is 0.92, so 92% chance that it's a channel. So like I said before, the value of all 6 attributes at this voxel increase the probability of it being this class. And just to break it down another way, the GLCM entropy and peak mag are going from that 33% chance building up. Adding in the curvedness, the peak frequency, the coherent energy, and the GLCM homogeneity all gives you that final classification of 92% chance that it's a channel. And so when you look at your force plots, in this case, we have three different possible facies. And so you can look at the force plot at that voxel for all 3 of your different potential facies classification. So if we look here at turbidites, there was only a 1% probability that this voxel was classified as a turbidite. And so you can see here that there were 2 different K curvedness and peak magnitude. The values of those kind of increase the probability that it would be classified as a turbidite, whereas the other 4, like the GLCM homogeneity, the peak frequency, they're blue, they're that lowering the probability that it's classified as a turbidite. And so same thing with background. You can see that some attributes are increasing the probability it'll be classified as background, some are decreasing it. And so these force plots help you understand the individual kind of local level prediction, and they're really useful for investigating possible misclassifications or areas where you're like, okay, this model really didn't quite give me the output. Like me as a seismic interpreter, I don't really think like at this voxel, it should be classified a channel. Let me see what's going on in the model. And so that's how it's most useful. So of course, we have more information on this and a lot of papers and more presentations up on our website. So thanks for listening.